Geometry nodes is the biggest thing to happen to Blender since left click. It not only lets you achieve things that were previously impossible, but it also gives you, the artist, much more flexibility to create complex objects and interactions with speed. And Geometry Nodes is just the start of the much larger Everything Nodes project. Future releases will add node-based systems for working with particles, simulations, and even collections. Since development is ongoing and constantly changing, this tutorial will focus on something small but common, which is scattering objects. In our case, scattering some sugar crystals on a little gumdrop. But the exact same method could be used to scatter anything, like the new rocks from Polygon, professionally scanned from locations around the world that go great with our new plants and photo scanned grounds, sand, dirt, snow, and grass materials. So start creating better renders today faster by signing up at polygon.com or clicking the link in the description. So geometry nodes can be added to any object, like our starting default cube here, and the way you access it is by changing any window, like this timeline here, to be the geometry node editor, which is it's got its own little node editor. So click that and you won't see anything until you click on new. Now if we zoom in here, you can see we have something pretty familiar. If you're familiar with shader nodes, anything like that, you've got an input and you've got an output. And basically, much like a conveyor belt, it's moving, in one direction, okay? And so, yeah, using the conveyor belt analogy, right? You've got, a plate of food on this end, and then like as it goes along, like a node will like add something to it, and then another node will like change that scale of that thing, and it'll go along and it'll do a bunch of stuff, and then what you end up with at the end there is what the actual geometry will look like. So that's the basics of nodes, just in general, right? So for example, we could add in right here a transform node, which could be used to add rotation to our cube. We could let's say move it along the x-axis a little bit. We could scale it a little bit. We could do a bunch of stuff with this, but if we go into edit mode, you can see we've still got our original cube, okay? So these operations are happening after that because we start at this end with our edit and then we end up over here with the final object, okay? So, turn that off. So you could combine it. You could do some interesting stuff like a Boolean operation, right? You could perform a Boolean operation on itself, right? And now you've got like some fun stuff that you could do, right? Geometry nodes is cool. You can do a lot with it, okay? So in our case, what we want to do though is the most common thing that everyone wants to do when they start with geometry nodes is scatter stuff, because also, that was actually the goal of the first implementation of geometry nodes, was to create a scattering stone demonstration. So if it can do that, it means they hit their goal. And yeah, that's why everyone's doing scatter stuff. Anyways, so what we want to start with is, and by the way, I'm hitting Shift A to bring up this add menu if you weren't aware. But we want to start with a point distribute node, and there's no reason you should know that, so don't feel bad. Point distribute, we want to plug this into our geometry, and we won't see anything until we take this and put this into our geometry output, okay? So it always has to be connected to the output in order to see it. And when we do that, with this density value here, you can see we get a whole bunch of points, but we have lost our cube. And the reason for that is we have replaced the geometry with points, and now we've just fed points, right? So if we want the cube as well, which we do, we want to combine it with a join geometry node, okay? Which is something that you end up using a lot because you do a bunch of stuff and then you want to combine it with the original. So you join it together like so. And by the way, my join node will look probably different to yours if you're using 2.92. And that is because there is a new input that will actually combine things in 2.93 on. So basically you can cram as many inputs into this this thing right here. It's not just like, it'll accept as many inputs as you throw into it, which is really cool. I love that idea for a node. So yeah, anyways, look at that, got some points. So we want our points to become sugar crystals. So first of all, we need to create a sugar crystal for it to instance. So I'm gonna add in a cube, move this to the right here, scale this down like so. And since we have changed the scale as well, you can see our scale values have changed. I'm going to hit Control A and apply the scale. Okay, so what we need to do is after our points have been created, because that's what this is doing, you could almost call it the point creation node instead of distribute. But anyways, we want to instance something. And there's no option to do that in here. It's a separate node. So we're going to hit Shift A, point instance, okay, and drop this in right after it. Our points have disappeared until we click our little eyedropper here and select an object, the cube. Ta-da! So now all those little points have become a cube. Very easy. Now, the scale of this matches 1-to-1 of these, which by the way is great. Using the old particle system, you could never get the scale exactly right. You had to kind of match it up and guess, but this is an exact 1-to-1, which is cool. But let's say we wanted to change the scale, and like, yeah, we could change the scale of that, but it's annoying to have to like apply it, and yeah, it's just annoying, right? So yeah, how would we change the scale? Well, there's a number of ways. That's what's really cool about geometry nodes, is it's really flexible. And one way to do it would be to add a point scale node, which is pretty self-explanatory. You drop this in right here. Now, by the way, the order of these things, like you might be thinking like, how would I know to put it in between these two things that could equally go after it? And like, yeah, I guess. But I guess after it's been instanced, it's no longer a point anymore. It's like an object, right? So in order to scale the points, you have to put the points. Anyway, you sort of learn it as you become more familiar with it, what sort of order is. It's very new at the start, right? Don't feel bad if it's like, oh, I'm overwhelmed. Anyway, the point scale, this is how we, that's how we change things, okay? So it hasn't done anything currently. Our points have just disappeared. And the reason for that is that point scale by default will scale it according to an attribute which you would put in here. Now we'll talk about attributes soon, but an attribute can be anything. In our case, or in this case, let's say you wanted to just scale it along a single value. Vector is what you would be after. Now, vector gives you 3 values, and the reason for that is that there are 3 axes. The x-axis, the y-axis, and the z-axis. Okay, so you can scale it on each of those independently, do some fun stuff, or you could click, drag down, and then you can scale it along all 3 at the exact same time. Okay? Now that's cool and all, but generally when you are instancing something, you don't want them to all be the exact same scale. If it's a rock, if it's a tree, if it's a whatever, you want it to have some slight variation between it, okay? So we're going to remove that by hitting Control X, which will delete a node but keep its connection, handy tip. And I'm going to hit Shift A now, and not in points here, we are instead going to go up to Attribute, and there's a whole bunch here. All these nodes are pretty fun to play with, but the attribute randomize node is what we are after. And we're going to drop this in here. Okay, now again, hasn't done anything, but looking at it, you'll notice you got a bunch of words at the top: float, replace, create, whatever. You'll get more advanced as you go along, I'm sure. But there's 2 values here, minimum and a maximum value, which is really good. And that's what we want. However, nothing has changed. And the reason for that is that this is an attribute node, meaning we have to put an attribute in here for it to drive something, okay? Because otherwise it doesn't know what to drive. What are you trying to randomize, okay? So sometimes you'll see the value would pop up there, depending on, I think, if you've referenced it already along the chain. And I think also this is a 2.93 feature that the pop-up appears. Otherwise, you have to manually type it in, scale. And when you do that, it now knows scale is something to reference, and now it has scaled it randomly. Now, the usability of this, like I actually passed on that feedback to someone at the Institute, like, yeah, it is a little daunting to have to know what to type in before something happens. So I think the drop down helps with that, but in this case it didn't include scale, so I don't know what's going on. Anyways, so this is cool. The cool thing about this little, what I like about it is, like, unlike particle nodes or what, particles and particle instancing, is you've got like an actual value here. I know that like the start of it is going to be this value and then the maximum is going to be this value. You don't have to like guess and do everything by eye. It's actual values there, which is really handy once you're sort of like figuring out, like, okay, the smallest size of my crystal I want there to be is sort of like that size, but then the largest size I want it to be like maybe 3x that, so something like that. So you can kind of do that, whereas with particles it was really hard to figure that kind of thing out. And you've also got seed value, right? So you can change that to anything and it'll just randomize it and pick a different one to make it big or small. Pretty cool, right? So that is one randomization. What about rotation, which is the other really big one that people generally want to randomize when you're scattering something? So let's move this along, and we would drop it in right here next to it, or before it. Actually, it doesn't matter. Scale and rotation could be either or. So I'm going to duplicate it, just move it to the right, and now this value, this one does actually pop up. I don't know why, but it's rotation. If you don't see it pop up, just type it in manually, make sure that it's spelled correctly, rotation, and you should see that we've now got some random rotation. Now, something to note is that this rotation isn't exactly random, okay? Because there is 3 axes in which it can rotate on. A float value will not rotate along all 3 axes. It's sort of doing it, I don't know, is it doing it evenly across all 3 at the same time or something? Anyway, what you want to do instead is change this from float to vector. And just like before, you've now got 3 of these values to change from, 0, 0, 0, 1, 1, 1 as the minimum and maximum. And also to really confuse things, these values are, I should have looked it up before I started. I was going to do that. But basically, it has to be any value over pi, which I guess is like 3.4 something, in order for it to do a full rotation. So whatever these values are is based on pi. I don't know. Anyway, generally all I do is I just click, drag down, and then just go with my mouse, right? And just drag it to the right. Anything over 3 or whatever will randomize it. I don't care what it becomes, just so long as it's more than 3.4. And look at that. We've got randomization everywhere. And just quickly as well, if you were perhaps building a scene using some of the new rocks from Polygon, and you wanted to rotate objects just on the Z-axis and not have the rocks flip around or whatever, you could do that just by rotating the bottom value there, which is the Z-axis, which is cool. I don't know how, like in particles, every time I was like building a scene that needed to like rotate trees or something on that axis, I'd be like, oh, how many... Like I could never remember the exact, like whether it was normal or tangent and like which one was the rotation. It was so confusing. Could never figure it out. But anyways, it's easy now. So we've got it rotated it on all axes, which is good. Haha. Now, something to note with geometry nodes is that geometry nodes is, yes, it is influencing the mesh here, but it is actually a modifier. So if you go to the modifier stack, you can see that our geometry nodes there is appearing. And if you were to do, normal stuff with a modifier, you can disable it, appear it, make it disappear in a renderer, etc. But you can also add stuff before it or after it. So if you were to add a subsurf modifier, it'll slow down a little bit, and it's now subdividing the cube as well as each of these little points individually, right? So you could rearrange it. See? It's pretty cool. And also there's, by the way, a subsurf modifier inside the geometry nodes that you could use as well. But anyways, something to note is that it'll disappear. Geometry nodes will disappear if the modifier is not actively selected. And selected is a new thing for modifiers, by the way. Didn't used to be, but now you can select things inside the modifier stack. So when it's got this blue outline on it, that is selected. Yeah, that was something that I came across when I was using it. I was like, where's my modifier? Like, where's my geometry nodes gone? I'm like clicking, I'm moving around. And it's because it wasn't selected. So it is annoying because generally I only have one geometry node thing selected for the whole time I'm working anyway. So you can click this little pin icon, and that way you can, select and do things and it'll always remain there. So that's handy. Okay, but let's talk about something else that's really cool with geometry nodes. You can expose a value. All right. So for example, this density value here is a value that I might want to change later on. So I'm building a scene and whatever, and I realize I need more or less rocks. It would be cool if I didn't have to, open up geometry nodes and like, oh, where's that node? Which is the one with the density, and then find it. Well, you can expose it by clicking and dragging to the input right here where it's got density max. And now the value there has gone, but it has appeared over here. Isn't that cool? And to make it even cooler, if I hit the N key, N for Nelly, with that node, with this selected, has to be, no, it doesn't matter which one's selected. You can see that I've got it there, density max is what it's called, but I can double click it or click this and type in a name for it that I would be familiar with. Sugar amount. Okay. And look at that. So you can see this is really handy once you're building like a full scene and you've got like rocks, trees, plants, and a bunch of other things. Like you could have like different values for different things. In fact, the actual scattering stone example that was is provided on the blender.org homepage, it shows you exactly that. So they've labeled things, and you can see how an artist would really love a tool that's well built, because you can just go through ideas really quickly, which is great. So it's awesome. Okay, now we want to start making this look like, what do you call it? A gumdrop. I keep thinking it's called a jube, like a sugar jube, but that's not, is that a thing? Sugar jube? I don't know. Maybe it's an Australian thing. I don't know. But one thing to note though, is that our cube here, our gumdrop currently is 2 meters by 2 meters, which wouldn't be very good. So let's scale this down. So a gumdrop, I haven't seen a gumdrop in years. I don't know where they went. But I'm guessing at most it's probably like 2 centimeters. So with my dimensions here, I'm going to click and drag down, and I'm going to type in 2 centimeters. I don't know what that is in inches, penny farthings, or whatever it is you Americans use. About the size of 1 nickel. I don't know. But it's about that big, right? Now, because we've changed the scale, I'm going to apply the scale, Control A, scale, and what the hell just happened? Now, sometimes when you do this, you might actually see that all of your particles, I keep thinking of them as particles, their points have disappeared. And what's actually happened is that they are still there. And actually, let's move this sugar cube over. Scale it down to be relative to the size of that. Apply the scale. Okay, so it is there. All right, we have two little sugar cubes. Why is it no longer reading our sugar amount value there, right? Like, why is there not 300 sugar cubes there? That was my question. Why is there not 300? Well, it's because you're still thinking of that as particles, and it is not particles. It is points, and points are based on the volume, the size of the world, okay? And how big your object is in that volume, how much space it takes up. So if I was to scale this in edit mode and just scale this up, you would notice that as you scale it up, more and more and more points appear on it, okay? Whereas then when you scale it down and down and down, the points reduce until it is what it is, which is 2 centimeters, right? So I find it actually helpful. This is a weird analogy, but think of it like bug splats, okay? And like a highway, if you've got a truck, the bigger the truck, the more bugs are going to splatter against it. Whereas the smaller the car is, or a bike or whatever, there's going to be less chance of it hitting a bug to the point that it's not going to hit any, right? That's the way I think of points. And the density, right? It's the density is how many bugs there are. And so therefore, if it's a small thing, it's not going to hit any, right? So anyways, that I don't know if this is going to make it confusing, like when we get to like, I want exactly 10 rocks to appear on my plane here. Like what density value is that? I don't know. Somebody did mention on Twitter there might be a value in the future for like points per face, which might make things easier. But for now, it's this. Now the problem with this is that when you're working with an object of this tiny small scale, what I'm doing right now is I'm moving my mouse and I'm dragging up over here, and I still haven't got nearly enough sugar on it, right? And also what the problem is like once you get to around about like 100,000 particles or something, it's hard to count. Like how many zeros is that? Is that 4 or 5 zeros? You kind of have to, and it's annoying. And I was thinking like, oh, this is annoying. I wish I could change this to like a value of like 10 and then have it multiply. And then I went, aha, geometry nodes, I can do exactly that thing. So let's change this to a value like 10 and then add in a math node right here, drop this in, and then multiply it by any value we want. 1, 0, 0, 0, 0, da-da. And now I have some values here which would actually make sense to me, and I can move my mouse left and right, and it is multiplying it by that amount, which is what we do because we're working with a really tiny, tiny object, and we need to have some dense points on it. So there. Really cool. And actually, I discovered also that that's exactly what they're doing for the Blender demonstration file with the stones, is they had a multiple thing as well. And I was like, aha, all right, I'm on the right track. So Anyway, very cool. Whoops. Yeah, 10,000. Make sure it's, yeah, sit around there. Okay. Let's make this look a little bit more like a sugar dube gumdrop. I'll move this up. Let's increase the subsurf. And how do you make it look like a sugar tube? Well, all you got to do is inset the bottom face. So if I just inset it slightly, it's now got to wrap around it, and you can see it starts to look like a little gumdrop. And then I can take my top face, move this down, squash it, and then scale this in. Haha, wouldn't you know it, we have a gumdrop. Now, a really simple thing we could do to improve this. All these little sugar crystals look the same because they're all copying this one object. And that's not the case with sugar crystals. Some of them can be like long and short or whatever. So first of all, sugar crystals are generally beveled. So I'm going to hit Control B on this and just give a little bit of a bevel. That's it. Then I'm going to duplicate it and I'm going to create, I'm going to make a couple of them of sort of like different sizes and shapes, which I'm sure everyone knows how to do. That's like a flat-ish looking one. And then I'll do one more, and then I'll actually like create like a clump, right? Like something like, I mean, I'm trying not to like ruin the bevel, so I'm trying to just select one of these parts like this. Okay, and then I'll hit L, and then let's move this around. So I just want to create, yeah, the appearance of like a clump of crystals, because I noticed that when I was looking at references that it can sort of look like a clump. But anyways, I'm sure you are familiar. You could probably guess how to do this because obviously it's just still copying the one. And that's because it's just referencing an object. We want to reference a collection. So first of all, let's move our sugar crystals here to a new collection. Let's go M and then go new collection, sugar crystals, hit OK, and then collection, select sugar crystals, and then by default, it's going to reference the entire collection. Don't know why that's the default, but we want to change it to just individual objects randomly. And look at that. It starts to look a little bit closer to sugar crystals on a gumdrop. And while this is mostly a geometry nodes tutorial, I do want to quickly show you how I set up the scene with the lights, the plane, etc. to get that lovely gumdrop look. Most importantly, the sugar crystals, you need to select them and just uncheck shadow so it doesn't cast a shadow. Give it this material. And the most important one of all is the gumdrop, which is this material. Now, normally I would explain things, but that would make this tutorial twice as long as it already is, and we just want to focus on geometry nodes. So copy this if you want to follow along and get that exact result. Otherwise, in the next part, what we'll be doing is using texture to drive where those points actually appear, and then also using another texture to drive like big and small shaped particles as well. So doing some more advanced stuff with geometry nodes. So click here to join me in the next and final part of this little mini series, and I will see you there.